In this session, I will be talking about the data frame and what is the data frame, how do you handle the data frames in R, what are the various techniques and tools that are available to work with data frames. These are some of the aspects that we are going to look at. So quickly getting into the agenda part of it, the introductory aspect of data frames is something that we are going to look at. One of the most important functions when we are working with the data frames, getting the summary of the data. What, what would typically come out as a part of the summary? How would I interpret the data based on the summary? So we would spend some time on that. Then if I have to get some kind of subset of a data frame, so how do I use the subscripts and indices to get a portion of a data frame? So if this is my entire data frame, if I want to get only some sub portions of it, then how do I use the subscripts and indices to get the subsets of a data frame? So we'll spend some time on that aspect as well. Then if I want to select only a few rows and only a few columns from the data frame, I don't want all the rows, all the column. I want only a subset again. So how do I really work with that? Then if I have to sort my data frame, so data frame you can look at it like an Excel table or for that matter any table of data, right? I'll talk more about it, but yes, if I want to sort the data frame, what are the kind of commands that are available in R? Now if I want to do the selection based on some kind of rules and condition, okay, I want to select the data only about the males, I want to select only those people whose income is above 100,000. So some such kind of logical conditions if I have to give to select the data. What are the kind of options that are available for me? If at all there are some missing values for some of the observations, so R typically handles the missing values as NA, not available. So if at all my data contains these NA kind of values, how do I really handle them? What are the different mechanisms I have to handle the missing values in the data? Some kind of ordering tasks, not a simple sorting, but if I have a complex ordering process, how do I take care of that? And a few other important aspects which I have to keep in mind when I am working with data frames. So probably if I have to put it in simple few sentences, data frames is all about handling your data. How well you are able to handle your data, especially which is present in a tabular kind of a format, similar to a spreadsheet kind of a format. If at all you have data, how do you handle that kind of a data in R is what is the essence of the entire data frame, right? So let's get into it. So a quick introduction of the data frame tells me that it's an object with n number of rows and x number of rows and y number of columns. So it's as good as m by n. If I am saying data frame is of size m by n, there are m rows in it, n columns in it. So looking wise, it looks more or less similar to a matrix, but there are a couple of differences between the matrix and the data frame. When we are saying something is a matrix, right, if this is a matrix, all the m rows and n columns only should be numbers. The entire, all the m by n values should be numbers only if I have to call that as a matrix. But in case of a data frame, the body can be either numbers, right, not necessarily only numbers. I can have text values, I can have dates, I can have logical variables like true, false. So which means all the n columns that I'm talking of, right? If all the values of all the columns are purely numbers, then I can call it as a matrix. But if all the values are not necessarily numbers but of the same type, okay, it might be possible that this all the values in this column could be logical. All the values of this column, they are dates. All the values of this column could be characters. But it can't be like part of it is character and part of it is date. That is not allowed. But as long as all of them are of the same type, I can still call it as a data frame. So the rows contain different observations, right? I can get the details of one single customer or the details of one single car. So the rows are containing different observations from the study or any kind of measurements. Typically, we call the rows in this language we call them as cases as well. And columns are the different headings which are otherwise called as variables. So columns contain the variables which are the headings to the data. Rows contain observations which are otherwise called cases. Now, if you have a not regular data, different kinds of vectors, right? You have different kinds of vectors. You can very well bind them into a data frame, right? Even if you have some raw data, you can make it as a data frame. Even if you have different kinds of vectors, you can make them into a data frame. So let's look at that simple aspects first. Alright, this is the data frame that I wanted to work with, right? I've got the data present in customer underscore segment.csv file. I want to use that file for our understanding of the whole of data frame. So I'm using the read.csv function. So I'm reading a CSV file that is present at this location. I'm bringing it into R. But okay, let me just bring that in. But initially, let me do these couple of aspects here. So the first point I want to talk about is, let's say I have three different kinds of variables, right? X is a variable containing numbers 1 to 4. Y is a variable containing characters. So let me call them A, B, C and D. So Y is characters. Whereas Z is another data frame containing logical values. True, true, false, true. So Z is containing. So all of them have the same size. Now I can create another variable called A, wherein I can create these three vectors. I can combine them as dot data frame x comma y comma z. So these three individually they are vectors, but okay, it's a warning message that there are no headings to it. So let me just see what A contains. Okay, I have to really bind the stuff. Alright, so I'll say A as dot data dot frame. I have to do a binding. C bind. I'll do a binding of x comma y comma z, and then I'm converting it into a data frame. So C bind is nothing but I'm doing a column binding. Now when I say A, I get X, Y, Z created in the form of a data frame. Probably if you just check the class of A, we will get it as a data frame. So this is one way I can create a data frame, right? Or Even by doing a table, I can very well create a data frame as well, right? If I have discrete numbers, right? So probably let me take some binomially distributed random variables, right? So I'll say bin, that's the name of the variable. Randomly I will use R binom kind of a function. If you look at R binom kind of a function, or R unif, we'll use R unif or R binom we will use. So let me say what it contains. R binom, which is nothing but randomly I will generate binomially data from a binomial distribution. So I have to give n. N is talking about number of observations, size, number of trials, how many times I want to execute it, and the probability of success. So the three things. So we'll talk about, so bin I will give as the name of the variable. R binom is the name of the function. Let's say an experiment be done 10 times, right? And this experiment is performed 100 times. So out of every 10 times, I'm talking about the probability of success, which we are calling as prob. Let's say we are calling it as 0.3. So it is like NCX. So N is 10 and X is 30, probability of success is 30%. And this experiment we are repeating 1000 times. Out of 10 trials, we are talking about success of 30%. So based on that, I am generating some binomially distributed data, right? So, oh sorry, we are talking the other way. First, we need to have n. N is number of observations. So let me put it the other way then. Initially, let me put 100, saying 100 times the experiment would be performed, and out of 10 trials, 30% is the probability of success. So these are the way I got all my bin values. Now I can do a table of bin where I will get saying that in this data there are 1 zeros, 19 ones are there, 19 times there is a possibility of 1 success, 21 times there is a possibility of 2 successes, 28 times there is a possibility of 3 successes, and so on. Now this is a table. Right now, if you look at the class of this table, it says the class of it itself is a table. The class of it is a table. Now, what I can very well do is I can convert even this table into a data frame. So, from the discrete data, I can simply get the table. Once I get the table, I can convert it into a data frame. So, it will give me the bin values, which are the groups, and the frequency associated with each of the groups. So you have different ways of creating the data frames, right, which is very clear here. So you can do the binding of a number of vectors, different types, but you can bind all of them doing a column binding, and you can still use this use this function as.data.frame to convert from any type into a data frame. So I can even convert tables to a data frame. I can even convert the different kinds of vectors into a data frame. So we know that lots of ways in which I can convert the things into the data frame. Now we are talking about the customer related data again. So let me copy this data. Now if you see this, I have a CSV file which talks about the different customer segments. It is present in this particular folder, and because it's a CSV file, I am trying to read it into R using the read.csv function, and I have assigned that to a variable called customer, which I would be using henceforth. So now let's see the process. I want to first import the file into R. So this file is imported into R. What are the few basic checks that we can do once we get the file into R? The first thing, if it's better if you want to attach the data frame. So you look at the type of it first, class of customer. So it says it's a data frame. Now there is sometimes if you want, you can attach the data frame so that from the next time onwards, if you have to refer to some of the columns of this particular data frame, you don't need to refer to the data frame dollar column name. Otherwise, whenever you have to refer to a particular column, always you have to refer to it like this. So our data frame is customer. So you have to always refer as customer dollar whatever is the column name I want to access. But if you have done attach customer, from next time onwards you can simply work with the column name itself. So that's one thing. If you want, we can do an attach, but right now I don't want to attach the data frame. Then apart from that, we can also check the names. Names is nothing but the headings of the data frame, right? So I can say names of customer. So I get that age is the heading, gender is one heading, income, kids, own home, subscribe, segment. So these are the headings that are present. So these are the different variable names that are present for this data frame. Now I can also use the functions like head and tail. So I'll say head of customer, which will show me the first few entries. So head gives me the first few entries of the customer saying age is this, gender is this. So this is the first customer whose age is 47.3, male. This is the income. He has 2 kids, doesn't own a home. He has not subscribed for a product. He belongs to suburb mix segment. So that is how we get the details of the first 6. And I can also look at the tail, which will give me the last 6 observations. So at least this will tell me that there are 300 customers in my data, right? 295, 296. So these are the details regarding the 295 and 296 customers as well. And then we can also use another command called dim, which will talk about the dimension. How many rows, how many columns. So this entire data is 300 rows and 7 columns altogether. So these are some of the information that I can typically make out, right? So all these things we generally give one after the other the moment we get some kind of a data frame into R. Any kind of an Excel data, any kind of another spreadsheet data you get into R, the moment it is a data frame, all these commands we do one after the other to get a high level overview of the stuff. And much more important compared to all these things, I want to take the summary of it. Yeah, and before the summary, I even have one more function to use always, str. str is the structure of the data frame. So I'll say str of customer. So it's a structure which says age is a number variable. So these are the numbers. Overall, the data frame has 300 observations of 7 variables. Age is a number variable. Gender is a factor, right, with 2 levels, female and male. And female is treated as 1, male is treated as 2. Income is a number. These are some of the initial numbers. Kids is an integer, 2, 1, 0, so on. Own home is a factor with 2 levels, no and yes. Subscribe is a factor with 2 levels, no and yes. Segment is a factor with 4 levels, moving up, suburb mix, etc. So this is what is being clearly projected by my structure function. Now I can very well go with the summary, one of the most important functions for us to have a quick look at, right? So let me talk about this. So in the summary, first thing, there are a few continuous variables, a few factor variables, right? Numbers, integers, they are all continuous. So age, For age, it has given the values in some manner. Same thing with income. So per age, it has given minimum, first quartile, median, mean, third quartile, maximum. Same is the case with income, same is the case with kids, because they are all quantitative variables, are basically continuous variables. Whereas if you look at gender, own home, subscribe, segment, they are all factor variables. So in case of factor variables, the summary has automatically done the counting of each of the factors. Females 157, males there are 143. Similarly, people who don't own a home, there are 159 people. People who own a home are 141. 260 people have not subscribed for a product, 40 people have subscribed. 70 are in this category, 100 are in this category, and so on. So that is what is the initial summary that is produced. So if you look at the continuous variables, so there are 6 headings that have come out. There is an arithmetic mean, which is the parametric computation, and you have non-parametric, which is also a 5 value summary. You get a minimum value, you get a maximum value, the median, the 25th percentile are typically you call as quartile 1, and 75th percentile or quartile 3. I don't need to talk about them in detail. So these are the 5 values that are being produced by the summary. Even I can get a little bit with a small difference. I will get 5 number function also. I can use 5 num, another parameter. I can use 5 num of customer. Okay, it needs to be done for each column. So let me use phi num of customer $age. So these are the 5 numbers here. The minimum, right? The first quartile, the median, the third quartile, and the maximum. So I can get even a 5 number summary for each one of them. So probably I can look at, instead of age, I can look at income. Now you will see some small difference. You see here, you are not seeing any difference, right? 114, 278 is the maximum. 61,419 is the value here. Whereas the third quartile is 61,403. So median is the same. Q1 is 39,656. Here it is coming out as 633. So a small difference comes in the way the 5 number summary is presented, because we will get the value of the hinges in the 5 number summary. I'll talk about it. We will get the value of the hinges, not the Q1 and Q3 when we are using the Tukey's 5 number summary. And when we are talking about the categorical variables, each factor is typically counted and the summary is produced there. And a few more things that we can typically do is we can use a few functions. By is a very important function that you can do, and even the aggregate, especially if I want to summarize the data frame based on the factor level. Based on the different factors, if I want to do a summarization of the data frame. So in this case, let's say I want to find out the average income by gender. I want to find the average income of the people for males separately, for females separately, right? Now this is where I can use the by as a function. The first thing I have to give is, in by, the first thing I have to give is which variable I want to summarize. So I will have to say income, but because I have not attached the data frame, I have to say it as customer $income. So that is what I want to summarize. Now by what? By gender. Gender wise I want the average income. So the second parameter that I give to this function, second argument that I give is the gender. So I'll say customer $gender. Then the third thing is, what is that I want to find out, right? Income, gender wise. Now what is the summary I want? Is it the mean? Is it the standard deviation? Or any other function that you want to give on your own? So this is where if I simply say mean, I will get the mean value. So it says female, the mean income is 52,859. Whereas for males, the average income is 48,824. Well, not only the mean, you can give any kind of a function. Let's say you give SD, you will get the standard deviation. So it says the standard deviation of female income is 19,000, whereas in case of males, the income is standard deviation is 20,000. So the volatility of the male income is much higher compared to that of the female. Or you can write your own functions also, right? You can very well go ahead with your own functions. You can even take a linear regression on the top of it, whatever it is. Or you simply say function of x, right? Where you are setting standard deviation of x divided by mean of x. That is what is the name of the function, let's say you are creating. So now it says the standard deviation divided by mean for female is 0.36, for males it is 0.42. Probably that is what we otherwise call as coefficient of variance. So we can very well say that the coefficient of variance is higher for males compared to that of females. So sometimes we can write our own functions also as a part of by. So that is the way we can use the by function. And similarly, I can also use the aggregate as well, right? So I can do the same thing using the aggregate. The same set of functions I can use using aggregate, right? Let me try. But here aggregate gives a better representation. If you see aggregate, I say customer dollar income. But here I have to give the second one. The only thing is I have to give it as a list, right? Even if I have only one, the gender, I have to give it as a list, but I can give it many more also, not just one. So I can give it as a mean, the third one. Now this comes in a tabular representation. This is also a data frame here. This comes as a list. If you look at the class of both the outputs, that's one major difference that you have to be comfortable with. The output that comes out of the by, right? If you are talking about, so this is a separate class in itself. Whereas if you are talking about the class associated with the aggregate, it's a data frame. The class that is associated with by is still a by, but the class that is associated with the aggregate is a data frame. That's one of the prime reasons compared to the by, I will be more and more using the aggregate itself if I have to perform the same set of tasks. You see the numbers are the same, but the way the presentation is done is completely different in case of using by versus in case of using the aggregate function. And in case I have some kind of logical variables, they would be coerced. True would be taken as 1, false would be taken as 0 for all kinds of averaging purposes. And if there are any kind of non-numeric variables, then the warning messages are also being displayed saying that this particular function will not be applicable for this kind of a variable. So some such kind of things you can very well look at. Then moving on to the next aspect where we are trying to look at the various subscripts. If I want to really get a part of the data from a data frame, I am referring to using subscripts and indices. So wherever we are talking about subscript, we are using the square brackets, not the full bracket. I am not the regular bracket, we are using the square brackets. And within the square bracket, I will have to say rows comma columns. So the first one on the left hand side we are pointing to the rows, the right hand side we are pointing to the column. So we have to give, okay, if I say 3 comma 5, it says that you are getting the third row, fifth column value. That is it. And in case I want to get the entire range of values, I can even use the colon operator. So I can say 1 to 3 rows comma 5. So now let's start a few things out of this data frame, right? So if I say customer and put third row, fifth column, it says this is what is coming up. Own yes. Or if I say third row, fourth column, it says 0. The number of kids is 0. But if I want to get, right, if I want to get, let's say 1 to 10 rows, 1 to 10 rows, column number 3, then this is what it comes. 1 to 10 rows, the incomes of the people. And if I say I want the first row, but or I want 1 to 10 rows, 2 to 4 columns, then I'll get it in this format. 1 to 10 rows, 2 to 4 columns. So wherever I want a sequence, I can give it like this. Or if I say I want 1 to 10 rows, but only 2, 5 columns. So then I'll use the C operator. C 2 comma 5, it gives me only the second column and the fifth column, right? So I can get some kind of subsets, yes. And now if at all I want all the rows, right? Now within this is per rows, this is per columns, right? This is per rows, this is per columns in a subset. If I say I want all the rows, then I will leave this as blank. If I say I want all the columns, then I will leave this as blank. So you can check, we can check it now. Let's say I want to get 1 to 10 rows, but all the columns. So I'll specify 1 to 10 there, but I'll specify a blank here because I want all the columns. So you could see the data that is coming out, 1 to 10 rows, all the columns are being displayed here. So if I want all the rows or all the columns, just one additional step is I have to put that as a blank corresponding to the row or a column. And if I want only some specific rows or columns which are not in a sequence, I can very well use the C operator to typically do the concatenations of the rows and the columns. So a few of the functions here, right? When I am setting n comma, so rows, nth row, all columns. The other way is if I set it as minus n, means except the nth row, all the other rows, right? Get all the other rows except the nth row and you get all the columns. You'll get very clearly. So get the rows from 1 to n, all the rows from first row to nth row, get all the columns. This says don't get the first 1 to n rows, so get only after that, right? Minus is not that. So 1 to n rows minus. So don't get the 1 to n rows. So you get only the remaining rows, but all the columns from the remaining rows. So here it says you get the ith row, jth row, kth row. Only 3 rows you get, but all the columns from it. This says wherever your x value is greater than your y value, get only those rows. This is a kind of a logical testing that you are giving. Wherever the x value is greater than y value, get only those rows, but all the columns. And what does this say? You are putting blank in the rows. So get all the rows, mth column. get all the rows except the mth column, right? All the columns except the mth column. All the rows, only the 1 to m columns, not all the columns. All the rows, all the columns except the first m columns. All the rows, column number I, j, k. All the rows where in columns where x is greater than y. All the rows, get the columns 1 to m in a sequence, along with them get I, j, k, other 3 columns as well. Then it says get all the rows where x is greater than y and all the columns where a not equal to b. Only a few columns where a is not equal to b. And similarly here, get the rows 1 to n, I, j, k as well, along with all the columns. Now you could see these are different kinds of ways you can subset the data and get the appropriate subset from the overall data frame. And in some cases, I may be interested in getting a random also, right? Let's say here, I want some random 20 rows to be selected, right? I want some random 20 rows to be selected out of this 300. So first of all, I'll use a sample function. Sample is a function that will generate randomly. So I can say out of this 1 to 300, randomly select some 20 values where the replace equal to false, means don't repeat. So get 20 unique values. When I do this sample, it will give me 20 unique values. So 93, 189. So this is done in a random fashion. Now what I can do, these row numbers I can give as an input to my customer. So out of my customer, so the rows, get these rows and get all the columns. So randomly 20 numbers will be 20 rows will be selected and would be displayed for me. So you could see row number 88 is displayed, row number 187, row number 255. These are the rows that are randomly selected by the system and are simply displayed. And let me tell you, this sample is always random. So once you redo it, you will get another set of people. 12, 237, 31. It's a completely random kind of a process. So if you want to, especially when we are doing bootstrapping process, where we are trying to get the subsets from the existing data in a random fashion, for creating training data, for developing different kinds of models, it is advised to use this sample function always. So randomly we are trying to get the rows from the data. So even from that perspective, to get the numbers randomly, we'll use the sample function, but the output of that sample function can be sent as an input to the rows while doing the subsetting process, and only those rows which are a part of the sample will be pulled and displayed. So in that sample I have already shown, if you are setting replace equal to false, it means each row is selected only once without any kind of a repetition. Right? Let's move forward. Then the next part that I'm looking at here is how to do a sorting of a data frame. Right, now that I got a data frame with 300 rows here, let's say I want to sort it on the basis of the age of the people here. Right, I want to sort them on the basis of age. Now this is where I'll say customer. Again, I'm taking a subset. The only thing I'll say is the order. Order is the name of the function I will use for the age column. So instead of age, I have to specify customer $age because I did not attach the data frame. And I'll take all the columns. Right? So I'm taking the order. Order is a function that I'm using. So I'll say customer order, customer age. So this will do the ordering based on the customer. But of course, because there are 300 records, it would be difficult if it displays all the 300 records. So probably let me just display the first 20 of them so that I'll see whether it has done a good job or not. So I'll check the first 20 of them. So that's where I'm taking a subset of the output that I'm getting. So initially what is that I'm doing? Order. Order based on the customer age. So there is an ordering that is being done. So and whatever is the order that is created, I'm simply referencing that particular order in the sequence in which it pulls out the data for me. So you could see here undefined column selected. Let me just do customer order only. I'll bring 1 to 20 later. Okay, so it has brought in. Oh, I have to give even the columns as well. Let me just redo it. So 1 to 20 rows and all the columns. Let me just give that. Now it is giving. So this is what is the lowest. 19.3 is the least stage. Order has done it in the ascending order. 19.3 is the least stage, then comes 20.7, then it is 21 and so on. So it has done in the ascending order. And now here if you see there are two people who are at 22.3. In this case, it follows the original data order itself, which means this is the 124th row, this is the 143rd row. So this is the same order it typically maintains if there are ties. Whatever is your original order. Here if you see there are three people at 23.3. The first it shows the 103 person, then it is 116th person, then it is the 122nd person. So that is what is the default structuring that the order or sorting is typically doing. So specify the order of the row subscripts before the comma. What are the rows on which I want to do the sorting? I can do it on one single column or I can do it on multiple columns as well. The column subscript I can let it blank because I want to extract all the columns in one single go. The original row numbers are retained. That is what we could see here. Right, in the sorted data it's not showing 1 to 20. It is generally showing the original row numbers itself. And if there are ties, the rows are typically presented in the original order itself. That is what I have already discussed. If I want things in a descending order, not in an ascending order, the same thing, instead of doing an order, put REV before it. Right, instead of order, put it as reverse order, reverse of order. Put it as reverse of order, all else remaining the same. You will get it in the descending order. So the highest stage is 80.5, then comes 78.2 and so on. Now here there are three people with 68.1. So the original order of the data itself, because the data became descending order, so even this is coming in the descending 191, 184, 155th customer. So wherever there is a tie break, it will retain the original order itself. And in some cases, I want to do the sorting not just on one variable, but I want to do it on two variables. Let's say I want to sort it by age, and wherever there is a tie break, wherever there is a tie, I want to break the tie, right? Wherever there is a tie, I want to break the tie based on income. Now you could see here 68.1, this is the ordering that is there, right? 51,000 is the, so 191 is first, 184 is second, 155 is third. But now I want to put it in terms of income. So I want this person to come first, then this, then this. So this is where I can think of bringing in the second variable, let's say income as well, right? Customer dollar income, bring that as well. Now you could see the tie break is broken in this way. First it is the 184th row because this is having a highest income out of this 68.1. So it does only between the 68.1s. Wherever the tie is coming, the tie is broken through the second one. And if the tie is there even after the second one, I can think of giving the third one as well. So that is the way the typical sorting is happening. So separating a series of variable names by commas, that is what we are doing. Initially we have given age, then we have given the income. I can add any number of variables in this fashion by separating them with commas. So the way R works is, it does the sorting purely based on the left hand side variable, the first one, and in case tie is coming up with respect to the first one, then the sorting comes onto the second variable. And even if the tie does not get resolved at the end of the second variable as well, then it moves on to the third and so on. That's a typical way it does the sorting process. Is it fine? Alright. Now, the next topic that I'm going to look at here in this session is using a logical condition to select the rows. Not just row number 1 to 20, right? Something like that. I want to use some kind of a queries based on which I want to select the variables. So based on the values that are present in one or more variables. So within the subscript associated with the rows, so within this, I will put the rules here so that only those rows are retrieved. For example, in this data, I want to get only the subset of those customers, right? I want to get the subset of those customers who have subscribed only. So I could simply say customer. I don't want all the customers now. I want only a subset of guys who subscribe, right? This so I have to take this variable customer dollar subscribe is equal to, here is equal to, when we are doing a comparison we'll use a double equal to, is equal to, let me say sub yes, means those customers who have subscribed. So let me put this in double quotes. And so these are the rows I want. I don't want all the rows. So only where this logic is true, I want only those rows but all the columns. Now you could see here it is retrieving only those rows. Okay, 20th row. Yes, they have subscribed. 53rd row, that customer has subscribed. And overall you could see these are the only customers who have subscribed. So directly I can set some kind of an equality kind of a logical condition, and based on that I can pull out only those rows which are meeting the, so which is a kind of a requirement which will typically identify which rows are meeting the condition, and it will pull only the subset of those particular values. Similarly, I can also put, right, more than one column, more than one condition. I can put all those things. Probably let's say I want those kind of customers whose age, right, let's say for this data, whose age is greater than the mean age and whose income is also greater than mean income. I want only those kind of customers, right? Now even that function is simple. You take your customer, you want to take the subset of the customers, but yes, all the columns. So now rows wise, what is that you want? Customer dollar age should be greater than the mean of customer dollar age. So the overall age of the customer should be greater than the average age, and I'm putting another rule. Similarly, customer dollar income, the income of the customer should be greater than the mean customer income itself, right? So only those customers I typically want. Now this way it will give me only this set of customers have the age greater than the average age and even the income greater than the average income, right? So this is how we can use the logical operators and or also I can use, right? Just like this for and, I can use this for or, and I can use even this one for not, right? Probably the same thing I can very well set it as not of this, right? I can very well set this as not of this, so I should not get these set of people. Not of this is not all these, so you'll get the remaining set of people who did not come in the earlier lot, right? Because those are the ones who are not meeting the condition. Now if you see here the sixth person, the sixth person would have come here, right? The sixth person has come here because that person has met both the criteria. But when I put not of, so the sixth person is missing from here. So that is what is can be performed even through not. And so even that is one more way we can typically go ahead with the process. And even in terms of columns, right? Let's say I want to get only numeric columns, right? Not all the columns. I want to get only the numeric columns. I can use this kind of a function, right? Let's say in this I want to get only all the columns where numbers are present. So within the customer I want all the rows, right? But I want to get only is numeric kind of column. So I'll use an sapply kind of a function wherein I'll apply it on the data frame, the customer, and I'll set is.numeric. Is.numeric is the function that I am applying across all the customer, all the columns. Sapply is applying something across all the columns of the data frame. So when I look at this, you see here I'm getting only the columns which have numerical values. We have only 3 columns which have numericals: the age, the income, and the kids. So out of the 7 columns, because these 3 columns have numericals, that is where only these 3 columns are being retrieved for us. The same logic you can go ahead, right? Let's say I want to get only factor. I can set is factor. So you'll get the remaining 4 columns which are factors. So that way, if you want only specific subsets, you can very well get using the sapply, because sapply applies a formula across all the columns one by one. So whatever is the formula you are trying to apply at a column level, you can very well retrieve that stuff as well. And now, to drop a particular row or rows, to drop a particular column or columns, I can very well use negative subscripts. We have already discussed about it. So let's say I want to get out of this customer, let's say 1 to 20 rows, but I don't want the 5th column to be produced, or I don't want the 5th column to be retrieved. Then only 1, 2, 3, 4, 6 and 7 columns are being retrieved and displayed. So the negative subscript will drop a particular row or drop a particular column. So even you can use the negative subscripts with respect to the concatenate, the C function, or you can use them as a sequence. Any of the kind of operations can very well be used with the negative subscripts as well. Then One more thing in case of logical selection of the variables is the which function. It identifies the location of the vectors which are meeting a specific criteria. I can give a specific criteria, and based on that, if I want to know which rows are meeting this criteria. So if I say which, and let me say age, customer dollar age greater than 65. So which rows are typically meeting the age of the customer above 65? Now it says these are the rows 155, 156, 157. So if I really want to get only these rows, I could also use the which function. I'll use customer. In the subset, I'll use this which, saying these are the rows that I want and all the columns. So comma blank. Comma blank is all the columns. So only these customers data would be retrieved for us, right? So that is one more operation that we need to be comfortable with. All right. Now, moving on to the next concept here. How do I really handle missing values? Any rows that contain missing values, especially in your spreadsheets, if there are any kind of blanks in any of the rows, they would be typically treated as NA. When you are getting them into R, you could see that there will be a few NAs. Now, the response variable, one of the important things for us to understand is when we are doing some kind of modeling at a later point, let's say linear regression using LM function or any other regression models using generalized linear models. Any of the models that we are building, the response variable should not contain any kind of missing values. If my model has to be a very good statistical model, the response variable that I am looking at, it should not contain any kind of missing values, no blanks at all. So what we say is, these are different kinds of mechanisms that we have to really remove all the rows that contain NA. If at all any of my rows contain NA or blanks, I can simply do NA dot omit. So if you want to remove, let's say in this customer, if there are any kind of NAs, I could have simply done NA dot omit customer. What it does is, it really sees if there are any rows containing NAs, that row will be completely deleted from my list. So if it does not have anything, fair enough. Now I can check the dim just to see if there are any rows that are omitted. Of course, here it's not having any, so nothing got removed. But if any one of the rows is having NA, that gets removed altogether. The same logic I can use for exclude as well. Right? Instead of NA.omit, I can also use NA.exclude. If at all, that's also one more, there's a small difference between them, but otherwise I can use NA.omit is very commonly used, but I can use even NA.exclude as well. Even in this case, if I am looking at the dim, seeing any records lost, because there were no NAs, nothing got lost from my data. So I have two different functions which are doing this job. In some cases, if I really want to check if this particular case is complete or does it have some kind of NAs in it, then I can very well check complete dot cases. So if I say complete dot cases of customer, for each customer it will really see if this case is fully complete with all the details or does it contain some kind of NA. So wherever it contains NA, it will give me the output as false. but if it does not contain NAs, it will give me as true. So which means I can very well do this complete cases, and I can even get the subset from the customer. So the input that I can give, these rows you get and all the columns. So even this could be another mechanism where I can retrieve only those cells where NA is not present, So it's a good alternative to NA.omit, but of course this is a very simple function, whereas this is becoming more and more a complicated kind of a function. But these are the different ways in which I can do this in R. Now, it is very much possible that if I'm looking at the missing values, right, instead of one row, two rows, if you look at one or two variables altogether, probably this variable itself could have majority of the missing values. So instead of removing the whole row, I can think of removing this column as such. Now this is one more kind of stuff that we can do. If at all I am able to identify that most of the missing values are coming from one single column, better remove that column from the modeling purpose rather than trying to remove all the rows of data where other column values are present and lose valuable information as a part of the modeling process. Rather than removing those columns, it's better that you start removing, rather than removing the rows, you can think of removing that one single column which has a good number of NAs in it. Now this is where you can think of applying some kind of function like this, right? Apply. So you look at it within the data, look at the columns, right? 2 is the column. So within the data, look at the columns which have NAs. So that is the apply function is doing. So the first apply is within the data, look at for each column compute whether it is NA or not. Now, so your values will become true, false, true, false. Now out of that data, again look at the column, count the number of trues. So which will tell you how many NAs are there overall. So if I simply say apply, right, if I simply say the first apply is I want to look at my data, which is my customer. Within this customer, column wise, I want to check for is.na. This is the function I am applying. So it will give me true, false, true, 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 false. So wherever each column it will check for NAs. Wherever it is NA, it will give true, otherwise it will give false. Now that would be my columns that would come up. Now what is that I'll do? I'll apply another apply on the top of it. On this new data that I have got, I will simply look at the column wise. I'll take the sum of how many such trues have come up. Now it says in all the cases there are zeros only. But if it comes out like in one column there are very large number of NAs, then better I omit that column from my further analysis rather than trying to delete all the rows from the data. So this is one more way. Initially you try to look at how many NAs are there in each of the columns, and based on that you can take a call whether I should remove the whole column from my analysis or should I focus more and more in terms of removing the rows which are containing NAs. In some cases it's even worth enough replacing NAs with zeros. So wherever I come across NA, right, let's say I will set is.na of my customer. So wherever I am getting NAs, I will simply replace that. So I'll put customer across. So wherever I am getting NA, I'll replace that with a 0. So this is one more model. If I want to replace my NAs with 0, I can simply do this activity. Again, if I look at dim of customer to see whether my data got changed, it did not get changed anywhere because there are no NAs. But in case you have NAs in your data, you can handle it even through this way. If at all, for some of the rows, some of the data, any NAs should be replaced with 0 or some other default values. You can very well do this kind of a process as well. Then another important aspect that I want to use is eliminate pseudo replication. Right? I don't want the values being repeated. Right? I don't want any duplicates. So let's say I want only the unique values of one single column. Right, based on one single column, I want only the unique values. Let's say from this data, I want one from each segment, and that too people with highest income. Right, I want people with highest income, one from each segment. This is what I want. So probably I can first give customer new. So first let me order the data because I want it the people with the highest income, the one single person with the highest income from each segment. So this is where I'll say reverse order customer dollar income. So I am doing the reverse order of the customer income. So that is the rows I want, and I want all the columns. So this is what is coming as a part of customer new. So in this customer new, I want the subset where it is the name is not duplicated, the segment is not duplicated. So this is where I'll say cus new. Within this I am taking a subset where I don't want duplicated. So this is where I am calling not duplicated. The name of the function that I am using is not duplicated, and cus new dollar segment. So within this, I want this segment to come out to be unique. Now you could see I'll get only 4 rows of data because only 4 segments are there. So it has come like traveler segment, the highest income is 114. In suburb mix, the highest income is 85,000. So probably it's like from each segment, pull out the one with the highest income. If that is the kind of a requirement, first sort the data, then after that remove the duplicates. So I can very well remove the duplicates using not duplicated. Right? So I can get the subset of the rows which is not duplicated using the not duplicated function. So duplicated is the name of the function. I put a not before it. So initially I am sorting it and I am using the not in front of the duplicated function. So you have to just think through the logic. Different kinds of features are very much easily extractable from the data using some of these functions altogether. Now, the next part which is worth looking at is complex ordering. In many cases, let's say I want to sort one thing in one column in an ascending order, whereas the other column I want it in a descending order. So this is one common scenario. Till now, whatever the 2 variable sorting that I have taken, we have taken both of them in the same order. So either I have used reverse order or normal order. Normal order will set it in ascending, reverse order will set it in descending. But what if I want one in ascending, one in descending? This is the place where I can simply set, right, customer. I want the order based on age. So here I want it as an ascending order. But with the income, I want it in a descending order. Age I want in the ascending order, but income I want in the descending order. So that's where you put minus. Minus will change the order. Within the order, if you are putting a minus, that will change the order. So first it will do the sorting or ordering based on the age in the ascending order, and the moment you have put minus customer's income, it will sort it in the descending order. So if you look at wherever the tie has come out, you could see it should sort in the descending order of. So here we will see there are two incomes, two ages same. The sorting has happened on the income. So here two ties, there is a tie for the age, descending order of the income. Again, there is a tie for the age between these three. The sorting is based on the income in the descending order. So this is the way we are talking about complex ordering, where one is in the ascending order, the other one is in the descending order. So we are using order, but putting a negative sign before those variables where I require the descending order. But yes, this is more and more applicable for numerical variables only. But if I want to do the same thing in terms of the scale variable, in terms of the factor variables, I just need to put rank. Let's say I want to put it segment wise. Right? I want to put it segment wise. Instead of just putting a minus segment, I have to put it as minus rank of segment. Because rank will convert it into a text, into a number. The text into it gives a ranking. So now if you see wherever the tie has come, okay, these all are from the travelers only. But wherever if you have from different segments, then you could see that it would do in terms of the descending order of, you see here 45.5. These are the three people with 45.5. So the first one is travelers, the other two are suburb mix. So because we are talking about the descending order here, it comes travelers first, then the suburb mix. So the way we are trying to retrieve the information makes a lot of difference. So this is what we are talking about, complex ordering. And coming to the grep, right, generally we will not use it. But if I want to get only a few specific columns, not all the columns, and that too those columns which are matching with a particular field, let's say I want to simply look at those columns which have E within their heading. So I'll put grep. I want to search for small e in the heading, so that's where I'll put names of customer. So I want to search for a letter E as a part of the names of the customer. So it says the name E is, the letter E is present in 1, 2, 3, 5, 6, 7 columns. So I can very well get this columns as a part of my output. So grep can be used to compare a particular string, and based on that, if I want to retrieve a set of rows or columns as a part of my output. So even that could be very well understood for pulling out the subsets from the data. Alright. Next talking about a few more important tasks that we can really perform using data frames. So if I want to eliminate the duplicate rows, right, remove duplicates kind of stuff, all the variables which have exactly same values in two or more rows are typically called as duplicates. So I can very well get the unique as a function. Unique as a function will remove the duplicates altogether from the data, right? The remove duplicates or unique as a function will remove the duplicates from the data. So you can very well say customer equal to unique of customer, so that all the duplicates will be removed. Right, here we don't have the duplicates, so we don't have an issue here. Right, but whenever there are some duplicates in the data, I can simply say unique of the duplicates, or I can very well find out which rows are duplicated. Right, I can very well find out which rows are duplicated by using this function called duplicated. Duplicated of customer. When I am doing, it will identify which rows are duplicated. So it gives all others are duplicated. They are not duplicated. So it is giving me false across. So nothing is duplicated, but wherever it gives me true, it means that those particular rows are typically duplicated ones. I can think of removing those duplicated. So even that's one more way of removing the duplicates from the data. So duplicated as a function will identify for each row whether this particular row is duplicated or not. Similarly, unique is also another function which can remove the duplicates. So the entire thing, wherever it is matching, it would be identified as a duplicate and it would be simply removed. Now, the other thing is, what if you have dates in your data frame, right? So if there are dates in the data frame, by default, they would be coming out in a character string format. Right, let me get in a few dates. That would be better. Let me take another simple data frame. So let me call it D1, wherein I am giving some dates. Right, let me take it as 01/01/2016. I'm taking this as one date. Right, even if I get it in Excel sheet, it would be more like this itself. Then I'm getting 10/1/2016, 25/2/2016. Then I'm also pulling in let's say 18 18/10/2016. So let's say this is the way I've captured my data, right? So I'm calling D1 is these things. Now, if I look at the class of D1, it is character. This is the way, even if you are getting a date from an Excel sheet into R, by default, it would be in the format of a character itself. But I can use this function called strip time. Strip time is the function that I have to use to convert these dates into the right format. So the format that I have to give, now if you see the way the data is entered, this is my date. Then there is a hyphen. This is my month. Then there is a hyphen. This is a 4-letter year. So now if I have to give it, let's say I want to give the D2, which are the actual dates. I'll use a function called strip time, for which I'll give D1 as my input, the date that is there in the text format. But the format of it I have to give, okay, the first part is the date. So that's where I'll give it as %D. %D means it's the date. Then I have a slash. Then I have the month. The month I will give it as %M. Now let me tell you, if the month is in this format, I'll take it as %M. But if it is in JAN, FEB kind of a format, then I'll take it as %B. So there are different kinds of code for different representations of the dates. So you can simply search on you can simply search on the different kinds of formats for different kinds of date. I'll produce it in another video separately. But if you are immediately looking at it, better search them for each kind of format. What are the typical codes that you have to give it in R? Similarly, then you have a slash, and then you have a 4-digit year. 4-digit year is represented with percentage capital Y. If it is a 2-digit year, you will represent it with a small y. If it is a 4-digit year, you will have to represent it with a capital Y. Now this part you mention it as format equal to and put this entire thing in double quotes. Now this should be stripped into the time format, date time format. Now you put D2. This is how it gets converted. You see here, year hyphen month hyphen date. This is what is the typical or understood format for the date. If you look at the class of D2 also, you'll typically get it as POSIX. So it's more of a position based timing, right? So if you use your strip time kind of a function, it is typically this kind of a format which is more and more associated with the date objects. So even if you are getting them into from an Excel sheet, by default they would be showing in a character kind of a format. You can convert them using the strp time kind of a function, which would convert them into dates. Then if you want to do a matching, right, let's say you have two different data frames. I want to look up for this particular value in this particular data frame and based on that retrieve the stuff. So let's create a couple of things here, right? Let's create two data frames from our customer data. So I'll call df1, right? I'll call it as a data frame where I'm converting it as a data frame. I'll take the table, right? I'll take the simple table of the segment, or let me do two aggregates. That would be simple, right? So let's do two aggregates. df1 we'll call it as aggregate. Let's do income, customer dollar income, by, let me take it as customer dollar segment. Segment wise I am taking the income. I'll take the mean income. So that is what I am calling as df1. So this is df1. Similarly, I'll do a df2 wherein I'll do the aggregation, right? This time I'll do it for age instead of the income, segment wise. So this is what I got df2. Now, so these are the two things that I have, right? I have the customer, I have two different data frames. This data frame containing the age of the customer, probably it's better. df1, let me rename the df1. So then df1 I'll call it with the names. Let me call them as segment, and I'll call it as mean income. So let me put it as mean underscore income. So these are the names I am setting for df1. Names of df2, just for simplicity or just for understanding the whole thing, I'll call it as just seg. Instead of segment, I'll just call it as seg. And this, let me put it as mean underscore age. So these are the names that I have set. Now, what I really want to do is I want to match, right? I want to match the names that are there, which are in the first column, right? From the df1, corresponding to the DF1, I want to get the DF2 values. Now, if you typically see, I want to do a match, right? I want to do a match. I want to search for DF1 dollar segment. I want to match for the values associated with DF1 dollar segment, and I want to search it in DF2 dollar mean age. I want to match that, right? I'm searching for DF1 dollar segment in DF2 dollar mean age. That is what I have to match it with DF2 dollar seg. I'm doing the matching. So it says yes, this is found in the first row of this. This is found in the second row of this. This is found in the third row of this. This is found in the fourth row of this. Just for simplicity, let's do DF2 in a descending order. Right? Let me take DF2 as the order of, so DF2 order, I'll set DF2 dollar mean age. So you do an ordering based on the age and you select all the columns. So now your DF2 is this one. So first you will get urban hip, then moving up, suburb mix and traveler. Now I will try to see the matching. So now you see here the first one moving up is present as a second row. That is where 2 is coming. Suburb mix is present in the third row. So that's where this location is coming out as 3. Travelers, the third one, is coming in the fourth row. That's where it's coming as 4. So match is actually trying to match one particular value in one data frame with another value in another data frame with the same name. Is it getting just like a match function in Excel? It is trying to match a particular value in a data frame with the values in the other data frame. So wherever the match is occurring, it will pull out the location where that match has occurred. So that way it could be more and more useful. It's more like a lookup kind of a function as well. That is one more way you can pull out. Now you can very well pull out the age corresponding to each one of them, and you can very well add it to your data frame as well. So that's one more way. So probably now you can say DF1 is, you can very well say DF1 dollar age. Now you add one more, right? The DF1 dollar, let me put small h, wherein I'm doing a C bind, right? I'm combining it. So let me call it as data.frame, wherein I'm taking C bind of the existing DF1, and to that I will take DF2 of, I will take this one, these rows. DF2 directly I'll take dollar, that column, mean age column, where I'll take the subset as based on this. So now let's see if this got added properly or not. So I'm closing this here, data frame. Now if you look at DF1, I got more like this. Moving up, mean income, age segment, age mean segment, right? Age mean income. So because it is coming out as a data frame where it is pulling out the details from this particular segment. So DF1 is typically, oh, you are talking of DF1 dollar age. So I could have simply taken the age part itself. Why did I add all this? So these two columns are redundant, right? So probably it's better now I remove df1. I'll simply set it as only the df1 with all rows, only 1, 2 and 5 columns. Even I can do that later. Now data frame undefined columns. Okay, let me just check what is coming out here. The dim of df1, if I see, it is 4 rows, 3 columns. Oh, this entire thing is coming up as one single column itself. So one way is I could have removed this whole thing. I can recreate the stuff, right? So the thing is, instead of saying if I had taken df1 dollar age, I should have simply taken this part itself rather than combining again the whole df1 into it. So yes, so that's the way you can very well do a matching and based on that retrieve the values as well. Then comes the other important aspect in the data frames where you are looking at merging the two data frames. So let me again come back to my df2. This is my df2. Let me come back to my df1 as well. So these are my df1s and df2s now. Right, so this is my df1, this is my df2. Now names wise also let me change them so that you can understand things much better. So the df1 I have given these names, df2 I have given these names. Now let's say if I have to merge these two data frames, try saying merge df1 comma df2. It will not happen. The way the merging is happening is a simple repetition of the stuff. So this is my df1, this is my df2. You see all combinations of this with all combinations of this. This is the way the merging is happening. The default merging happens that way. At least one of the variable names has to be identical in the two data frames. If they are not, if they are identical, the merged data frame contains only those rows which has the complete entries. Here there is no row that is simply common between the two. So that's where the merging is happening in this way. But at the same time, if I set merge df1, df2 all equal to t, right? When I say merge df1 comma df2 where I set all equal to true. Now so all equal to true also is, I mean, if there are NAs, it will show if the other one is not having the values, if this one is having the values, so it will simply showcase NAs where the values are not present. But what is very important for us is if the headings are not matching, I have to use more like this. Merge df1 df2 by dot x saying which variable from df1 you have to use, by dot y will say which variable from df2 you have to use. So let's use it like this, merge df1 comma df2 where you say by dot x is equal to whatever is the column from df1. So you'll say, you'll put it as segment. This is the column you want to use from df1 and you'll say by dot y equal to seg. So this is the way you want the matching to happen and based on that you want the merging to take place. Now you see you get a different merge altogether. right? So if the names are same, you can simply say merge. But if the names are not matching, the merge will do all combinations. So in this case, it's always advisable to put by.x, saying what part of x has to be looked at. So what is the column in x that has to be compared? By.y will say what is the column in y that would be compared with. So wherever the matchings are happening, they would be retrieved. And based on this, you could also have said all equal to t, which will say even if one of them does not have values, they would be showing as NAs rather than omitting the values altogether. And finally, the summarization of the content of the data frame, we are all clear. We have used the summary variable very heavily. You know how to use aggregate and by function. So all these are different kinds of summarizations that you can very well perform on the data frame. So these are what are the important aspects that are associated with working with data frames. So if you are having any kind of queries regarding this, you can very well get back to me by giving me a call on the number that I have provided below, or you can even send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.